Before you drift into rest tonight, pause for a moment and let your thoughts slow. Everything you see, touch, and hear, every glimmer, whisper, and heartbeat, isn't truly happening out there as you believe. It's being recreated inside your mind, moment by moment. Welcome to Science Reshaped, a quiet corner of the cosmos where wonder softens into stillness and knowledge becomes a lullaby. Tonight, we set out on a slow journey through one of the strangest and most beautiful realms ever discovered, the world of quantum physics. Take a breath and make yourself comfortable. If these calm explorations help you unwind, gently tap subscribe and tell us in the comments where you're listening from and what time it is for you now. I always picture people scattered across the globe, some just waking, some drifting towards sleep, all sharing the same curiosity under one sky. Now, let your room fade into dim light. Imagine a single beam from a lamp falling across your hand. You think you're seeing the light travel from the lamp to your skin, but what you actually experience is your brain's recreation of that light. In the same way, what we call reality is a delicate reconstruction, a story the mind builds from waves and particles dancing in silence. This story, the quantum one, begins when the ordinary world stops behaving as we expect. It starts with warmth and color, with the glow of a flame or the gleam of sunlight. But when scientists looked closely, they found that light refused to act like a simple wave. It behaved instead like a collection of packets, tiny quanta, each one carrying energy in precise steps. At the start of the 20th century, Max Planck proposed something radical. Energy is not continuous, but arrives in small, indivisible amounts, each one a packet called a quantum. Later, Albert Einstein took that idea further. He said those packets were real. Light itself came in discrete particles we now call photons. With that single thought, he explained the photoelectric effect, the way light can strike metal and knock electrons free, a mystery that had puzzled everyone before him. The discovery meant that light, so soft and fluid to our eyes, sometimes behaved as if it were made of countless tiny bullets. From there, strangeness unfolded. Matter itself, the solid stuff of tables and stones, began to show the same dual behavior. Electrons, those invisible companions of atoms, could act both like particles and like waves spreading in space. What was once thought to be simple became a shimmering blend of possibilities. The closer we looked, the less certain everything became. Take, for example, the experiment that changed physics forever, the double-slit test. When scientists fired light or electrons at a barrier with two narrow openings, they expected to see two bright bands appear on the screen behind it, as if tiny bullets had passed through one slit or the other. Instead, they saw an interference pattern, a set of bright and dark stripes like ripples overlapping on a pond. Each particle seemed to travel through both slits simultaneously, interfering with itself as though it were a wave. And when the same experiment was repeated one particle at a time, the pattern still appeared, slowly, dot by dot, until the stripes emerged again. It was as if every single photon or electron carried a map of every possible route it could take and followed all of them at once. But when scientists placed detectors to check which slit the particle actually went through, the pattern vanished. The photons behaved like ordinary particles again, choosing one path instead of two. Simply measuring which route they took changed the result. Observation seemed to alter reality. This discovery shook our understanding of existence. It suggested that the act of measurement, of interaction, plays a role in shaping what is real. Reality was not fixed and waiting to be seen. It was a set of possibilities until something forced it to decide. To make sense of that, physicists like Niels Bohr and Erwin Schrödinger proposed the language of wave functions, mathematical descriptions of those possibilities. An electron orbiting an atom was not a tiny marble circling a nucleus, but a cloud of probability, a mist describing where it could be found. When observed, that mist collapsed to one location. The act of looking chose a single outcome from the spread of maybes. Imagine fog filling a valley at dawn. From afar, it seems uniform, soft, and undefined, but as you step into it, shapes begin to form. Trees, paths, stones. The fog hasn't disappeared. It has simply revealed one of the many landscapes hidden within it. The wave function works the same way, describing a fog of possibilities that condenses into one reality when observed. In this fog lives Heisenberg's uncertainty principle, the idea that certain pairs of properties, like a particle's position and momentum, cannot both be known precisely at once. The more accurately you know where something is, the less you can know how fast it's moving, and vice versa. This isn't a limit of our tools. It's a limit written into nature itself. The universe, it seems, keeps a little mystery at its heart. And yet, this uncertainty is not chaos. It's what keeps atoms stable, stars burning, and the world intact. If electrons could sit perfectly still, atoms would collapse. It's the gentle blur of uncertainty that gives matter its structure, a kind of cosmic breathing room built into everything we know. So, as you listen now, let that idea settle. Reality is not sharp-edged. It's a tapestry woven from possibilities, shimmering until a moment of contact gives it shape. Quantum physics doesn't just describe that shimmer. It invites us to see the beauty in it, to find peace in the notion that uncertainty and existence walk hand in hand. When you're ready, take another slow breath. Let the world around you grow quiet. We're only at the beginning of this journey through the quantum realm. Soon we'll explore how those same principles, superposition, entanglement, and delicate balance, build the very foundation of reality itself. But for now, let your thoughts drift. The universe doesn't rush, and neither should you. Electrons that dwell inside atoms do not circle like tiny planets. They spread in gentle, overlapping clouds of probability, each possible orbital layered within the broader wave function. Even whole molecules, carefully sheltered from every disturbance, have been coaxed into existing in two states at once, taking parallel paths like a traveler, somehow walking down both sides of a quiet street. It sounds impossible to picture, but try this. Hold a deck of cards face down in your hands. The top card could be a king, a queen, or any other. Before you lift it, all those possibilities coexist in the game. In the classical sense, the card already has a set identity. You simply don't know it yet. In the quantum sense, it truly embodies every option at once. Only when you flip it does the story collapse into one version. The difference is subtle but profound. Classical uncertainty means ignorance of a fixed truth. Quantum superposition means the truth itself has not yet been decided. It is as if the deck has been woven into every card at once, a shimmering blend of futures layered together. Why would nature behave this way? Because particles are not tiny billiard balls, but disturbances in deeper waves, and waves naturally overlap. Two ripples on water can pass through each other, forming patterns that appear and vanish in the blink of an eye. Superposition is simply that same overlapping carried to the deepest foundations of matter. As fragile as it sounds, this strangeness is more than a philosophical curiosity. It is the bedrock of modern quantum technology. Quantum computers, for instance, exploit superposition to explore many outcomes simultaneously. A classical bit in your laptop can only be 0 or 1. A quantum bit, a qubit, can be 0 and 1 together. When many qubits share that state, they examine an astronomical number of pathways at once. Picture yourself in an immense maze. A classical computer must walk each corridor step by step, testing every turn. A quantum computer, at least in principle, drifts like mist through every passage simultaneously, sensing the route that leads out. When a final measurement is made, the cloud of possibilities collapses into the correct answer. Of course, the real process is far more delicate, but the image conveys why superposition carries such promise. In ordinary life, we never see this. A chair is not both in the kitchen and in the living room. Your keys are not simultaneously lost and found until you look. That's because superpositions are exquisitely fragile. The environment, air molecules, light, vibrations, constantly interacts with objects, forcing each into one defined reality. This vulnerability is called decoherence, and it explains why the quantum world feels so different from the everyday one. Superpositions vanish quickly in noisy surroundings, surviving only in laboratories where scientists isolate their systems with immense care. Still, for a moment, imagine a world where superposition is visible. Imagine flipping a coin and seeing it hover as both heads and tails, shimmering between outcomes. Imagine reaching a fork in the road and walking both paths at once, only to discover when you look back that you've taken one. Imagine holding a glass of water that is both full and empty until you drink. These pictures are dreamlike, and perhaps that's the best way to hold them. Superposition is less about tangible intuition and more about accepting that reality itself is richer than the categories we use to describe it. Like a symphony waiting to begin, it holds many melodies, and only when the conductor's baton falls does one tune rise. The beauty lies not only in its strangeness but in what it tells us. That possibility is woven into the fabric of existence. Superpositions show that the universe does not hurry to decide. It lingers, holding options lightly, like mist before the morning sun. So, as you breathe slowly, picture an orchestra tuning in half-light, each note a potential not yet chosen. Picture a deck of cards glimmering with every face at once. Picture yourself moving down both sides of a quiet path. These are not riddles to solve, but lullabies of chance, reminding us that the world itself rests in many states before it settles into one. And if your eyes close now, let them. Your dreams too are superpositions, layered images and stories awaiting dawn to choose which remain. The quantum world is delicate, almost impossibly so. Those faint ripples of probability, those fragile overlaps of states, can vanish with the slightest touch. A stray photon of light, a molecule of air, even a whisper of heat can collapse them into certainty. To preserve their hidden balance, scientists build chambers colder than deep space, shielding their experiments inside layers of metal and vacuum. Within that silence, quantum states can live a little longer before reality intrudes. Think of a soap bubble floating in sunlight. It holds its round perfection for only a moment before bursting. Superposition is like that bubble, breathtaking, fleeting, gone the instant something brushes against it. To keep that bubble alive, we must remove the wind, the dust, the noise. In quantum laboratories, that's exactly what researchers attempt. They cool and isolate, creating conditions so quiet that even atoms hesitate to move. Inside such stillness, a single qubit can breathe. A qubit is not a particle itself, but a pattern, a small system that can exist as both 0 and 1, blending them together. It might be an electron's spin pointing partly up and partly down, or a tiny loop of current flowing clockwise and counterclockwise at once. This strange state is stored like a melody caught between two notes, fragile yet full of possibility. When many qubits work together, they weave an intricate harmony. Their combined wave functions form a vast space of potential outcomes, a map of all things that could be true. The trick is keeping that harmony intact long enough to extract an answer before the noise of the outside world breaks it apart. Every touch, every bit of warmth shakes the tune. So physicists invent clever ways to correct the mistakes the universe keeps whispering in. They use patterns of multiple qubits where one carries information and the others act as guardians, detecting and healing tiny errors before the whole song collapses. This is called quantum error correction, and it's one of the hardest challenges in science. Each new step forward feels like teaching a soap bubble to float through a thunderstorm without breaking. And yet, progress continues. Today's machines, sometimes called NISQ devices, short for noisy intermediate-scale quantum, still tremble with imperfection. They are not yet powerful enough to solve humanity's deepest puzzles, but they whisper of what's coming. They are prototypes of a new language, where computation is done through interference and possibility rather than logic alone. To imagine how they work, picture 1,000 violin strings. Each string hums softly, slightly out of tune, each vibrating in two directions at once. A quantum algorithm is the careful act of adjusting their phases, letting the wrong notes cancel while the right ones amplify. When the music ends, when the final measurement is made, only one clear tone remains, the answer. But if the air quivers, if one string drifts, the melody falters. That is the constant battle, to let the orchestra of qubits perform without interruption. It's why quantum computing feels almost magical and yet endlessly practical at the same time. It's the art of maintaining uncertainty long enough for it to reveal something certain. You might wonder, why build something so fragile? Because hidden inside that fragility is power. When we can choreograph these faint whispers of probability, we gain a tool that can model chemistry, simulate the birth of stars, and search enormous landscapes of data that classical machines can only glimpse. It's like learning to paint with moonlight, subtle, elusive, and astonishingly precise. For now, our instruments are still primitive. Most quantum computers are no larger than a refrigerator, their cores smaller than your thumbnail. Wires coated in gold descend into chambers colder than the background temperature of the universe itself. Each qubit hums faintly, waiting for pulses of microwave energy to guide it through its dance. Every calculation is a choreography between silence and vibration, between order and chance. In those frozen chambers, reality feels hushed. There's a beauty to that quiet, the kind that reminds us how thin the veil is between existence and possibility. Each qubit flickers like a thought half-formed, uncertain whether to appear or dissolve. And perhaps that is the deeper message of quantum physics, that the universe is not built from certainty, but from the gentle tension between all that could be. Take a slow breath and let that idea rest. Everything around you, every atom in your body, was once a vibration in that same quantum field, suspended between being and not being. The world we see is the settled version, the final note of a vast unseen symphony. As you listen, imagine the hum of that cosmic orchestra still playing beneath everything. It never truly stops. It continues quietly, even now, while you drift further into calm. Now we arrive at one of the most haunting concepts in all of physics: entanglement. It begins quietly, almost innocently, as a side effect of particles sharing the same quantum dance. When two systems interact and then drift apart, their states no longer belong solely to themselves. Each carries traces of the other, like two instruments that once resonated together, and now, even miles apart, still hum the same invisible tune. Imagine placing two tuning forks on a table. Strike one, and the other begins to vibrate as though it remembers the sound. Entanglement is deeper than that. Here, the connection does not fade with distance or time. When you measure one particle, its partner responds instantly, no matter how far away. Einstein called it spooky action at a distance. He disliked the idea intensely because it seemed to violate the rule that nothing, no signal, no influence, travels faster than light. Yet experiment after experiment has confirmed it. The universe allows correlations that stretch beyond ordinary cause and effect. To picture it, think of two dice crafted so that every throw lands on matching numbers. If one shows 4, the other always shows 4 too, even if they're rolled on opposite sides of the planet. But these quantum dice don't carry predetermined faces. They decide their outcomes only when looked at. Before measurement, they hover in superposition, each side equally possible. The instant one die is observed, the other's uncertainty vanishes. It's as if the very act of looking decides not just one reality, but two, joined by a silent thread. How can this be? Physicists describe it through mathematics. The wave function of the pair cannot be split into separate pieces. The whole system is one extended object living in a shared probability space. When we touch one part, we touch the entire pattern. No message travels between them. Instead, both outcomes are encoded in a single, non-local harmony that reality must honor. Bell's theorem, proposed in the 1960s by John Bell, turned this poetic strangeness into something testable. He showed that any world governed only by local hidden causes would obey certain limits. Bell inequalities. Quantum theory predicts those limits will be broken, and when laboratories performed the tests, with photons, electrons, even atoms, nature sided with quantum mechanics. The inequalities were violated again and again. Whatever binds entangled particles is not a classical signal, but an underlying wholeness that space itself cannot sever. Pause for a moment and let that settle. The cosmos, at its core, may be less a collection of separate objects and more a vast web of relationships. Every interaction we witness could be a local ripple in an already connected sea. Entanglement suggests that separation is partly illusion, that what happens here can echo instantly there because here and there were never fully distinct to begin with. In practical terms, this ghostly linkage has become a tool. Quantum communication uses entangled photons to detect any attempt at eavesdropping. The connection collapses if tampered with. Quantum teleportation, though it moves no matter at all, can transfer the state of one qubit to another across distance. These aren't scenes from science fiction, but demonstrations repeated in laboratories on clear nights. Beams of entangled light stretching across mountain valleys. And yet, behind all this precision lies quiet wonder. Imagine two snowflakes born from the same breath of air. They drift apart in the wind, land on opposite peaks, melt into separate streams, yet remain, in some subtle way, part of one event. Entanglement feels like that. A reminder that the universe was once compressed into something smaller than a grain of sand, and that the memory of that closeness still hums through everything it became. So as you breathe now, consider that every atom in your body may share faint ancestral links with atoms in the distant stars. The carbon in your hand and the light from Vega might once have been joined in the same quantum chorus, before the universe unfolded them apart. In that sense, we are not just observers of entanglement, we are participants within it. Every heartbeat, every photon that reaches your eyes, every thought sparking in your brain is part of this same ancient symmetry playing itself out. Let your thoughts drift with that idea. The space between things isn't truly empty. It's filled with invisible structure, with subtle coherence connecting what seems apart. When you gaze at the night sky, you're not just looking across distance. You're glimpsing a single fabric of being, shimmering with quiet correspondence. And maybe that's why the quantum world feels so unsettling, yet so peaceful. It reveals a unity we can sense but not fully grasp. Breathe slowly. Imagine threads of faint light linking every particle that ever interacted. Imagine the world as a tapestry woven from invisible relationships rather than separate threads. In that silence, the strange ceases to be strange. It becomes simply another way of saying that everything, in the end, belongs together. When we speak of measuring a quantum system, we often imagine a scientist pointing an instrument and taking a reading, a mechanical process, nothing more. But at the smallest scales, measurement becomes something far stranger. It is not merely watching what already exists. It is the act that brings one outcome into being from among countless possibilities. Every quantum object is wrapped in a haze of potential states, each awaiting its chance to be real. Before we look, that haze describes everything the particle could be. All its positions, all its energies, all its directions. The instant we measure, the haze tightens into a single line, a definite result. This transformation is called wave function collapse, and for a century it has stirred endless debate. What exactly causes the collapse? Is it our conscious observation, or is it the unavoidable interaction between a tiny system and its vast environment? Most physicists lean toward the second answer. Measurement is not magic performed by a mind. It is any irreversible exchange of information between a quantum object and the world around it. When a photon strikes a detector, when an atom bumps into another atom, the delicate superposition dissolves, leaving one concrete outcome. Reality, in this view, crystallizes not when we see it, but when it can no longer hide its traces. Yet the mystery lingers. Why does the wave of possibilities shrink to one particular result and not another? The mathematics can predict probabilities with exquisite precision, but it remains silent about why this specific universe, out of the countless that might have emerged, is the one that appears before us. Some interpretations, like the many worlds view, suggest that nothing truly collapses. Every potential outcome continues to exist, branching into parallel realities beyond our perception. In one world, the photon strikes the upper detector. In another, it lands on the lower. We experience only the branch that contains us. It's a bold idea, almost mythic in scope, implying an infinity of universes unfolding side by side, all equally real, all whispering the same equations. Other thinkers prefer simplicity, that the wave function's collapse is as fundamental as gravity itself, a rule of the universe rather than a question to solve. Whatever the truth, the mathematics works, and that reliability lets us build technology upon these mysteries, even if their meaning remains hidden. Pause for a heartbeat and think about how extraordinary that is. Our phones, computers, and GPS satellites operate because equations born from uncertainty describe the world better than certainty ever could. Each transistor, each laser, each sensor depends on quantum principles working flawlessly behind the curtain. We live in a civilization powered by probabilities. The next time you flick on a light, remember that the glow from the bulb flows because electrons tunnel through barriers they shouldn't cross. Every spark from an LED is a testament to the weirdness of quantum rules obeyed by trillions of particles at once. The everyday world is a symphony of microscopic miracles we have simply learned to conduct. At its heart, quantum physics teaches humility. It tells us that knowledge comes not from dominating nature, but from listening to it closely enough to notice its contradictions. It reminds us that certainty is a luxury of large things. At the foundations, the universe speaks in maybes and perhapses. And still, from those maybes, entire galaxies bloom. Close your eyes for a moment and imagine that delicate balance. A world continually collapsing into form, moment after moment, like waves meeting the shore and retreating again. Each observation, each heartbeat, each breath a pulse of existence choosing one version of itself. What we call now might simply be the universe making up its mind. If that thought feels too vast, let it pass like a cloud. There is comfort in knowing that uncertainty is not chaos but creativity. It allows the cosmos to remain alive, always capable of surprise. Without it, everything would be rigid, predetermined, a frozen sculpture rather than a flowing sea. So as you listen, let your thoughts settle into that quiet recognition. You do not need to grasp every equation or solve every paradox. You only need to feel the rhythm beneath it, the gentle oscillation between possibility and presence. In that rhythm, life itself finds room to unfold. The deeper we peer into the quantum domain, the more we realize that observation is participation. To observe is to take part in reality's self-expression, to be one small mirror in which the universe glimpses its own reflection. Perhaps that is why studying physics so often feels spiritual. Even when grounded in mathematics, it reveals that knowledge and existence are not separate pursuits, but the same unfolding act. Take another slow breath. Imagine the particles around you, in the air, in your skin, in the distant stars, all engaged in this ceaseless dance of definition and release. Each instant of awareness is a fresh creation, a spark in the darkness becoming form. And when that form fades, the potential remains, waiting patiently for its next chance to be. Rest with that image. The world, moment to moment, is being rewritten not by will, but by interaction, by every meeting of particle and field, by every exchange of energy. It is the universe breathing through us, composing itself again and again. When we zoom out from the strange quiet of quantum mechanics and gaze across the cosmic scale, it is tempting to think that all that small-scale uncertainty has little to do with the grand rhythm of galaxies. And yet, the vast and the tiny are not strangers. They are mirror reflections across an invisible bridge. Every sunrise, every nebula, every planet tracing its orbit is built from the same restless rules that govern electrons flickering in the dark. The universe is the grand echo of quantum laws made large. In the first fractions of a second after the beginning of time, when the universe was younger than an instant, everything that would ever exist was compressed into a field of trembling energy, a pure quantum storm. Tiny fluctuations, mere whispers in that field, were amplified by cosmic expansion into the seeds of all future structure. Those faint irregularities became galaxies, stars, planets, and finally us. The reason the night sky looks mottled rather than perfectly smooth is that the universe carries the fingerprints of its quantum childhood. Think about that. The randomness that we struggle to tame in our laboratories sculpted the architecture of existence itself. The same uncertainty that makes a particle's path blur also decided where entire clusters of galaxies would one day hang in space. Quantum indeterminacy is not chaos. It is the universe's creative brushstroke. It adds texture, contrast, and variation to the otherwise uniform canvas of reality. Without it, everything would have condensed into one dense monotony, and nothing could have ever unfolded. Cosmologists studying the cosmic microwave background, the faint afterglow of the Big Bang, see this connection written across the heavens. Those delicate ripples in temperature, measured in millionths of a degree, are the fossilized remains of quantum fluctuations stretched to astronomical size. Every photograph of that cosmic pattern is, in a sense, a portrait of quantum mechanics painted on the largest canvas imaginable. This is why many physicists say the quantum world and the cosmic world are two ends of one story. At one end lies the quiet dance of electrons and photons. At the other, the roaring symphony of galaxies expanding through space. In between lies us, beings woven from both silence and thunder. We are made from particles that remember those early quantum ripples, particles that once existed as vibrations in the same universal wave. When you breathe, the air you draw in is ancient. The oxygen atoms swirling into your lungs were forged in the hearts of stars that long ago lived, burned, and died. Those same atoms trace their ancestry back further still, to the very first quantum tremors. Your body, your thoughts, even the words echoing in your mind right now, are the matured descendants of those primordial fluctuations. Every inhale, then, is a kind of cosmic inheritance. Pause for a moment and feel that. You are not a visitor looking at the universe from the outside. You are part of its fabric, a continuation of the same equations written in living form. The boundary between observer and observed dissolves when seen from this perspective. The cosmos is not something we watch. It is something we participate in, moment to moment. Perhaps this is the quiet secret buried in quantum physics. At the smallest scales, nothing is ever completely isolated. Every particle, every field, every vibration is intertwined with everything else. Even the emptiest regions of space are filled with energy, constantly flickering into virtual existence and fading away again. This quantum vacuum hums beneath reality like a hidden engine, not void, but fullness disguised as silence. Physicists have tried to calculate the energy of that vacuum, and the numbers defy comprehension. If their equations were taken literally, the density of that unseen energy would be enough to rip the universe apart. Yet something balances it almost perfectly, leaving only a faint residue that drives the slow acceleration of cosmic expansion. That leftover whisper is what we now call dark energy, the mysterious force stretching galaxies away from one another. It may well be that the same uncertainty that governs a single electron's orbit also powers the expansion of the entire cosmos. It's humbling, isn't it? The smallest unit of unpredictability, a single quantum step, echoing across light years to shape the fate of galaxies. The pattern repeats everywhere: micro and macro, particle and planet, wave and world. The deeper we look, the more the boundaries blur, until it becomes clear that scale is only perspective. The laws remain the same, humming softly from atoms to stars. So, when you look at the night sky, know that the starlight crossing those billions of kilometers was born from quantum transitions inside the hearts of suns. Each photon streaming toward you carries a history of uncertainty, resolved into radiance. It left its home long before humans existed, and yet finds you now, as though completing a story that began before time had names for things. You, sitting here listening quietly, are the universe recognizing itself through awareness. And maybe that is what physics ultimately teaches us. That knowledge is not just about measurement or prediction. It is an act of reunion, the cosmos remembering what it is made of. Each discovery, each experiment, each thought whispered into the dark is another small closing of the loop between creation and consciousness. So rest in that thought. The quantum and the cosmic are not opposites. They are partners in an eternal dialogue. The smallest vibrations give birth to the largest forms, and the largest forms shelter the smallest vibrations. In that endless exchange, meaning arises. In that rhythm, we exist. Let your breathing slow. The air moves in and out, atoms shifting, probabilities collapsing, the universe rearranging itself with every heartbeat. And through all of it runs one quiet truth. Uncertainty is not something to fear. It is the source of everything that ever was and ever will be. Imagine standing before a great wall, smooth and tall, stretching endlessly in both directions. In the everyday world, if you threw a ball against it, the ball would bounce back. It could never simply appear on the other side. But in the quantum world, things are not so obedient. Here, particles sometimes pass straight through barriers that should have stopped them. This phenomenon is called quantum tunneling, and it is as beautiful as it is baffling. To understand it, we must remember that a particle is not a tiny marble. It is a wave of probability. When this wave meets a barrier, part of it reflects, but part of it seeps faintly through, like light bleeding around the edge of a curtain. Most of the wave fades away, but a small fragment survives beyond the wall, and sometimes that fragment becomes real. A particle appears on the other side without ever climbing over or breaking through. It's as if the universe quietly ignored its own rule, allowing something impossible to happen simply because possibility never truly vanished. This effect is not just theoretical. It powers the beating heart of our stars. In the blazing core of the sun, temperatures and pressures are immense, yet not quite high enough for hydrogen nuclei to overcome their natural repulsion and fuse. If classical physics ruled alone, the sun would never ignite. But quantum tunneling gives those nuclei a chance to slip through the barriers separating them. Against all odds, they meet, merge, and release light. Every sunrise, every ray of warmth on your skin is proof that nature bends her own walls through the soft persistence of probability. Even the ground beneath your feet depends on tunneling. Inside atoms, electrons are confined to their quantized orbits, not by rigid walls, but by delicate balances of probability. Occasionally, they tunnel from one state to another, giving birth to countless phenomena, from radioactive decay to the inner workings of modern microchips. Without tunneling, the universe would be inert, silent, and still. Instead, it is dynamic, endlessly finding secret paths between impossibilities. To make this vivid, picture a musician playing near a closed door. You cannot see them, yet you can still hear the faint sound of their instrument. The music has tunneled through the barrier, losing strength, but not vanishing completely. At the quantum scale, the same thing happens, not with notes, but with existence itself. A particle's song continues faintly on the other side, and every now and then it grows loud enough to be heard. This delicate behavior also reshapes how we think about time. When a particle tunnels, it seems to cheat chronology, appearing in a place it should never reach in the time available. Experiments have shown that tunneling doesn't involve traveling faster than light, yet it challenges our sense of sequence. It's almost as if the particle borrows against the future, repaying its debt the instant it reappears. Physicists describe this with equations, but poets might call it a whisper of eternity folded inside each moment. In laboratories, tunneling is no longer a curiosity, it's a tool. The tunnel diode, one of the earliest quantum devices, harnessed this behavior to create lightning-fast switches. Modern scanning tunneling microscopes use it to image surfaces at the atomic level, tracing shapes smaller than light itself could ever reveal. Each time the tip of the microscope moves across a surface, electrons tunnel across a gap thinner than 1/1000th of a hair, forming a current that tells us where atoms sit. Through tunneling, we have learned to see the invisible. But beyond the instruments, there's something deeply human about this phenomenon. It reminds us that barriers are rarely absolute. Even when reason says no, nature leaves room for a quiet maybe. Probability, not certainty, is what drives creation forward. The same principle that lets an electron pass through a wall also lets galaxies form from random fluctuations and lets life emerge from chemical chance. Tunneling, in its quiet defiance, is the universe's most hopeful gesture. Pause and let that idea rest for a moment. Every limit you've ever known, physical, personal, emotional, has its quantum echo. Some part of possibility always extends beyond the wall, and sometimes, just sometimes, it makes it through. In this sense, tunneling is more than physics. It's philosophy written in mathematics. It says that the impossible is not a wall but a veil, thin enough, under the right conditions, to let meaning pass through. If you could shrink yourself to the size of a subatomic traveler, you'd see that the universe is not made of solid boundaries, but of gradients, waves, and probabilities. Barriers blur, edges shimmer, and every obstacle carries the faint outline of a hidden doorway. To exist at all is to be constantly tunneling, from one state to another, from potential to actuality, from silence into sound. And so, as you lie still listening, imagine those countless invisible leaps happening inside and around you. Inside your body, electrons tunnel every moment, keeping chemical reactions alive. Deep within stars, nuclei fuse through walls they should never cross. Across the entire cosmos, tunneling shapes the music of matter and light. Reality, in all its grandeur, depends on particles forever refusing to stay confined. Let that thought drift with you for a while. There is comfort in knowing that even the laws of nature leave room for grace, for transition, for surprise, for emergence. Perhaps that is the quiet message of tunneling, that existence itself endures not through force, but through subtle permission. Time. It feels so steady, doesn't it? Seconds ticking in order, minutes following one another like beads on a string. We remember the past, we experience the present, we anticipate the future. And it all seems so absolute. But in the quantum world, time behaves with a peculiar looseness. It bends, stretches, and sometimes refuses to follow our sense of order. To see how strange this can be, consider that at the smallest scales, events don't always have a single, clear sequence. In quantum mechanics, cause and effect can blur together, each influencing the other in ways that defy ordinary logic. It's not that time stops, it's that the universe doesn't always insist on keeping score the way we do. Sometimes the question, which happened first, simply has no answer. This becomes even more fascinating when we remember that particles exist as waves of probability. These waves don't march forward like soldiers in a line. They spread in every direction, exploring both what has happened and what might happen next. When a particle moves from one point to another, it doesn't take a single path. It samples all possible routes. It's as if the universe is performing every potential story at once, then settling on the version that fits best when the curtain of measurement finally falls. The physicist Richard Feynman described this with what he called path integrals. In his picture, every event in reality is shaped by an infinity of histories. The world, then, is not a chain of causes, but a tapestry woven from countless overlapping threads of potential. Each instant, each motion, is the final harmony of many possible songs, most unheard, yet all essential to the melody that remains. And if that sounds poetic, it is because the truth often is. The more deeply science peers into time, the more it finds rhythm rather than rigidity. Even the so-called arrow of time, the flow from past to future, arises not from any law of physics, but from the way entropy increases, from order slowly dissolving into possibility. The universe doesn't so much flow as it continually rearranges itself. It's humbling to think that what we call now may not be a single moment sliding across a timeline, but an ever-renewing act of creation. The wave function collapsing again and again, writing reality one observation at a time. Time might not be a river we travel down, but a symphony that plays itself anew in every note we hear. Quantum experiments have even suggested that in certain setups, measurements made after an event can influence the results before it. It's as if the universe listens to the entire composition, not just one bar at a time, before deciding what the final harmony will sound like. To us, bound to our clocks and calendars, this sounds impossible. But on the level of quanta, the boundaries between before and after are soft, blurred, permeable. Think of a dream in which time feels both long and short, where events fold into one another with no clear order. That's closer to how reality behaves beneath the surface. The waking world we experience, the ticking seconds, the aging of stars, the cycles of day and night, is a large-scale echo of that hidden timelessness, smoothed into predictability so we can live within it. Yet even in our ordinary lives, we sense the deeper truth. A moment of awe, a sudden memory, a glance at the night sky. These can make time stretch or stop entirely. For that instant, we are not moving through time. We are resting within it, part of the same stillness that cradles every atom. Perhaps the quantum world doesn't contradict our experience of time. Perhaps it reveals what time really is, not a line, but a living fabric that includes all directions at once. Physicists sometimes speak of the universe as a block. Every moment that ever was or will be existing together, like pages already printed in a cosmic book. In that sense, the past hasn't vanished, and the future isn't waiting. Both are already written, their patterns unfolding endlessly in the quiet presence we call now. The act of living, then, might be the act of reading, of awareness tracing the words, one line after another, giving motion to the stillness. If that feels abstract, return to something familiar. Listen to your heartbeat. Each pulse follows the last, yet none are truly separate. Each carries the echo of what came before and the seed of what comes next. This is time as the quantum world knows it. Continuity without division, motion without distance. Every instant is both outcome and beginning. So what then is the true nature of reality? Is it unfolding or already complete? Quantum physics doesn't tell us which, only that our sense of sequence is part of the story, not the whole of it. The universe doesn't hurry. It exists fully in every flicker, every vibration, every point of space and time at once. Take a slow breath. Let go of the need to chase moments. Right now, the atoms in your body are vibrating in rhythm set billions of years ago. The same laws that shaped the first stars shape you still. There is no before or after in the deepest sense. Only this ongoing, shimmering act of existence. If you could step outside of time and look back at it, you might see something astonishing, not a line, but a vast glowing web of interwoven causes, effects and possibilities. Every heartbeat, every breath, every thought glimmering like a node in that eternal network. And though we can only travel one thread at a time, the whole design is always there, unfolding in silence. So as you rest, remember, time is not something passing over you. You are time, expressed for a while as awareness. And even when your thoughts drift, the universe continues, rewriting the present endlessly, patiently, perfectly. When we open our eyes to the everyday world, it all seems so definite. A cup sits on a table, not in two places at once. A tree stands outside the window, not blurred across possibilities. The air hums quietly, the clock ticks predictably, and nothing feels uncertain. Yet beneath this surface calm lies the same shimmering quantum fog, the same superpositions, entanglements, and probabilities, patiently weaving the illusion of solidity. How? Then, does the world become so stable? What happened to the strange overlapping realities that rule the atomic scale? The answer lies in something physicists call quantum decoherence, a quiet, universal process that turns the probabilistic into the predictable, the indefinite into the defined. Imagine holding a single snowflake in your hand, delicate, symmetrical, crystalline. Now imagine dropping it into a rushing river. In an instant, its intricate pattern dissolves, joining the larger flow. Something similar happens when a quantum system interacts with its environment. The fragile superposition, that careful blend of possibilities, loses its isolation and becomes entangled with countless other particles. Each collision, each whisper of contact, spreads information outward until the original quantum identity melts into the collective. What remains is what we call classical reality. In a sense, the entire macroscopic world is a kind of grand decoherence machine. Every surface that reflects light, every atom vibrating with heat, every breath we take participates in this endless conversion of quantum potential into classical certainty. We don't notice it happening because it happens constantly, faster than thought, faster than perception. Reality, as we experience it, is what remains after the wave function's infinite branching has been smoothed into one familiar storyline. To make it clearer, picture a spinning coin once again. In isolation, it can represent heads and tails at the same time, a superposition. But the moment it touches your palm, or the air molecules around it, or even the photons bouncing off its surface, its delicate quantum state collapses into one result. The coin chooses, not because consciousness demands it, but because the universe is perpetually measuring itself through endless, subtle interactions. This is decoherence, not destruction, but transformation. It's the reason your coffee mug doesn't flicker between locations, and why planets follow steady orbits instead of dissolving into probability waves. It's the universe's way of drawing boundaries around experiences, gently selecting coherence from chaos, and yet, the underlying quantum fabric never disappears. It remains everywhere, humming beneath the surface, like the ocean beneath a thin layer of ice. Each classical event is a frozen snapshot of deep emotion. Each solid object, a momentary agreement between trillions of quanta that refuse to stand still. Even our sense of identity arises from this quiet process. The atoms in your body are exchanging energy with the air around you right now. Every second, billions of interactions link you to the environment. Light touching your skin, heat leaving your body, breath mixing with atmosphere. You too are part of the great decohering dance. Your boundaries are not absolute. They are continuously maintained by the same delicate balance that shapes matter itself. Decoherence does not mean the magic of quantum reality is lost. It simply means that the universe prefers to show us one frame at a time, one reality per observation. The infinite still exists. We just see it filtered through the lens of stability. Scientists studying this process often describe it as nature's quiet editor, trimming away interference patterns that would otherwise make the world unreadable. Without it, every object would remain blurred across all possible states, and perception itself would dissolve. Decoherence makes reality comprehensible. It gives the cosmos narrative coherence, letting cause lead to effect, letting experience unfold in time, and yet, at the edges, in the ultra-cold labs, the silent quantum computers, the isolated particles floating in vacuum, we can still glimpse the deeper layer. We can still watch the world hesitate between versions of itself, undecided for a moment before settling. Those experiments remind us that classical reality is not separate from the quantum world. It is born from it every instant. So next time you touch the table beside you, remember, it feels solid because countless interactions between your hand, the air, and the wood have collapsed their mutual possibilities into one shared outcome. The world is stable, not because it is static, but because it is constantly choosing stability anew, billions of times each second. Perhaps that's the most profound idea of all. Reality is not a thing, but a performance. Every particle, every atom, every cell plays its part, collapsing, decohering, and re-emerging in an eternal act of self-definition. We, as observers, are both the audience and the actors, watching and shaping the show as it unfolds. So, as you breathe quietly now, let the solidity around you feel both comforting and miraculous. Every sound you hear, every texture you feel, is the echo of quantum motion slowed to human speed. The wooden floor beneath your feet, the light spilling through your window, even the pulse within your wrist, all are steady only because countless invisible choices are being made. Moment after moment without end, in the heart of that stability lies a gentle truth. Chaos and order are not enemies. They are partners in the same cosmic rhythm. Order gives us form, chaos gives us renewal. Together, they make the universe not merely exist, but become. Somewhere along this journey, a quiet question begins to whisper through the equations, one that no experiment can easily silence. If the act of observing a system changes its outcome, then what exactly is an observer? Where does the boundary lie between the world being measured and the mind doing the measuring? It's a question that drifts not just through physics, but through philosophy, through every human thought that has ever wondered, what does it mean to be aware? Quantum physics, in its humble precision, never claims that consciousness shapes reality. It only shows that interaction does. When particles meet, when light strikes a surface, when systems exchange information, the haze of possibilities collapses into something definite. Still, the resemblance between that process and the way we experience awareness feels impossible to ignore. Consider for a moment how perception itself works. Light enters your eyes, sound vibrates through your ears, touch ripples through your nerves, yet none of these signals are the world itself. They are patterns interpreted by your mind, translated into color, shape, and sound. In a sense, you never encounter the universe directly. You encounter your brain's best reconstruction of it, a continuous act of interpretation happening in real time. And that interpretation, much like a quantum measurement, selects one version of reality from countless possible sensations. Your consciousness, too, may be a kind of collapse, not of wave functions, but of potential experiences. At every moment, infinite sensations could reach you, but awareness chooses one, then another, stringing them into a narrative. You are both the observer and the phenomenon being observed, a self-measuring system where perception and existence merge. Neuroscientists can describe this in biological terms. Neurons firing, signals synchronizing, patterns forming across networks of the brain. But the deeper mystery, why awareness arises at all, remains as elusive as any subatomic particle. We can measure brainwaves, yet not the essence of what it feels like to be. And here, in that gap between data and experience, the quantum world seems to nod in recognition. Because at its core, physics and consciousness are both languages for describing transformation. Both are processes that turn possibility into presence. In the laboratory, a measurement defines a particle's position. In the mind, a moment of attention defines reality's meaning. The connection may not be literal, but it is beautifully symbolic. A reminder that knowing and being are forever intertwined. Philosophers have long debated whether the universe requires observers to exist in the way we experience it. Is the cosmos, without awareness, an uncollapsed equation waiting to be perceived? Or does it simply unfold, complete in itself, regardless of who's watching? Most physicists would say the latter. The world is self-sufficient, endlessly decohering and evolving whether or not we're here to notice. And yet, there's poetry in the idea that awareness, wherever it arises, is the universe looking back upon itself. Think about that. Every conscious being, from the simplest creature sensing sunlight to the human mind tracing galaxies, is part of the same quantum story. We are not outside the experiment. We are participants in it. The atoms that make up your body have been entangled, scattered, and reassembled countless times since the beginning of time. Every thought you have is a rearrangement of cosmic history, the universe reflecting on its own structure, moment by moment. And in that reflection lies something tender. Awareness does not need to control the universe to belong to it. It only needs to recognize itself within it. When you look up at the night sky, the photons striking your eyes left their stars millions of years ago, long before your life began. Yet their journey finds completion in your gaze. In that instant, light and consciousness meet, closing a loop that spans eons. You are the final step in a cosmic measurement that began with the birth of those stars. Perhaps that is the quiet truth buried inside all this complexity. Reality does not divide neatly into matter and mind, observer and observed. It is one continuous field, expressing itself in different forms. Atoms think through you. Energy dreams through stars. The laws of physics hum through every heartbeat. The universe does not need to be watched. It is already awake, in countless ways, at countless scales. Close your eyes for a moment and feel that. The awareness listening to these words is not confined behind your eyes. It is part of something wider, the same awareness that animates all living things, the same pulse that has moved through the cosmos since its first vibration. From the smallest fluctuation in a vacuum to the birth of galaxies, everything that has ever existed is connected by the same simple fact. It knows how to respond, and that responsiveness, that subtle act of noticing, may be what we mean when we whisper the word consciousness. You do not need to solve this mystery. You only need to experience it, to let yourself rest in the wonder of it. The world you perceive is not separate from you. It is your perception taking form, the universe painting itself in your awareness. Every sound, every breath, every thought is part of that art. And when you finally drift into sleep, the universe continues dreaming through you, tracing patterns that began before time began and will continue long after memory fades. So as you lie there, let this idea settle gently. You are not small and you are not separate. You are the universe in the act of knowing itself, quietly, peacefully, eternally. We've wandered through the strange, luminous landscapes of quantum reality, from superposition and entanglement to tunneling, decoherence, and the whispering vacuum that never truly sleeps. We've seen how the world, at its smallest scale, is not made of solid things, but of ripples, waves, and probabilities, of possibilities waiting to become real. And yet, in all that uncertainty, a quiet truth emerges. The universe is not chaos pretending to be order. It is order that sings through chaos, harmony playing softly beneath the noise. When you step back and look at it all, the trembling particles, the hidden fields, the light crossing galaxies, you might expect the picture to feel cold, mechanical, mathematical, but it doesn't. It feels intimate, alive, as though everything, from the smallest electron to the furthest cluster of galaxies, is participating in one shared rhythm, a rhythm that includes you. You are not watching the universe from the outside. You are made from it, sculpted by its laws, sustained by its energies. Every atom in your body once existed inside the core of a star, forged in nuclear fire before being scattered into space to one day become part of you. The warmth of your skin, the air in your lungs, the thoughts passing quietly behind your eyes, all are continuations of the same story that began nearly 14 billion years ago. You are the cosmos, briefly aware of itself. And the more deeply we explore the quantum world, the more we see that separation is a kind of illusion. The particles that form you are not isolated points, but threads woven into a universal web. The light you see, the heat you feel, the heartbeat in your chest, all of them are interactions, exchanges, resonances. Even emptiness is full of motion, the vacuum alive with restless energy. There is no true stillness, only the gentle hum of existence continuing beneath perception. Perhaps that is the greatest discovery of all. Not the equations, not the instruments, but the realization that the universe itself is a form of connection. Every observation, every thought, every breath is a bridge between possibility and reality, between matter and awareness, between the infinite and the now. And through those bridges flows something we rarely name in science, but always feel in wonder: belonging. Because in the end, quantum physics does not just describe particles. It describes relationship, how one thing influences another, how every part of the universe exists, not by itself, but through its interaction with everything else. We are not solitary observers. We are entangled with the world we see. Our presence shapes its story, just as its story shapes us. So, when you gaze at the night sky, you are not looking into distance. You are looking into history, light that began its journey before life on Earth began. And when that light reaches you, completing a voyage of millions or billions of years, it becomes part of your consciousness, part of your memory. In that instant, the universe is complete again, the loop closed, the observer and the observed reunited. Science may one day answer questions we cannot yet imagine, but perhaps its greatest gift is not certainty. It is humility, the reminder that we live in a reality far richer than our senses can contain, a world that allows both equations and emotion, both precision and poetry. For every fact we uncover, there remains an ocean of mystery, and within that mystery, a place for awe. So let this final thought settle quietly within you. The world is not built from cold machinery, nor from random chance. It is built from interaction, from possibility, from the delicate balance between knowing and not knowing. You, like every atom and every star, exist in that balance, steady and fragile, fleeting and eternal. If you close your eyes now, imagine the universe breathing with you, each inhale gathering the scattered light of creation, each exhale returning it to the sea of stars. Somewhere in that rhythm lies everything that ever was and everything that will ever be, held together softly by the same invisible threads that tie one heartbeat to another. And as the night deepens and thought begins to fade, remember this: you are not lost in the universe. You are what the universe has found. You are its experiment in awareness, its voice, its listener, its dreamer. So rest now. The cosmos is vast, but it is also home. And you, small, infinite, luminous, are part of its quiet song.